Welcome everyone to the second session in our series on HeadSpin and the HeadSpin product. I'm Brian Perea, VP of Product Engineering, and I joined the company over 4 years ago as the founding data scientist. So today I'm going to talk about the intro to, basically an introduction to data on the HeadSpin product. And we're going to start with a sequence of essential questions. So, these are questions that I hope that many of you have, and there may be additional questions, but the goal is at the end of this presentation for you to understand, or at least have a high level understanding of these questions. So what are customers trying to accomplish on HeadSpin? How do customers collect data? What does data even look like in the HeadSpin product? What primary data do we collect? And by primary, that means what are the raw data artifacts that we're collecting from these devices? How does capture even work? How do we capture this data? What are HeadSpin issue cards? And what's the significance of issue cards and impact time? Who consumes this data in our customers? And what are some examples of customer use cases? So that's a lot of questions, but hopefully at the end of this, we'll have at least a beginning to answering each of these questions, and everyone will feel comfortable in this space. So at HeadSpin, our mission is to enable customers to deliver flawless connected experiences, and that applies across all connected devices, applications, networks. And we do this leveraging, sorry, I just clicked through my slide here, but we do this leveraging what we call the Digital Experience Insights platform, which is built on top of a global device cloud. These are bare metal devices deployed in our proprietary appliance, which we call the P box, or in some cases the AV box. And essentially, these devices are connected to servers inside of this secured container. Those are deployed in 70 different countries, 100 different locations around the world. We support a variety of different deployment models, whether that's a part of our core deployment in the HeadSpin cloud, an on-premise deployment on the customer's location, or bring your own device model, where customers can bridge their devices to the HeadSpin cloud by way of this appliance. Customers, as we showed in the last session, customers can access devices via the remote control UI. They can also access devices via our debug bridge, so they can bridge the device to the local machine as if they're a device in hand on their desktop, or they can interface with devices via automation. And we have first-class Appium and Selenium support, and we support all automation frameworks via our debug bridge. So that's where the device cloud stops, and then the rest of the product, this Digital Experience Insights platform, is built on top of that device cloud. So this is the device cloud. You can think of it as collecting data from real devices deployed across the world on local networks, and that gives us amazing data to be able to work with to provide accurate insights to customers and to build amazing data sets for machine learning and analysis. So, so we deploy the P-box, on site, and enable customers to debug at what's called at the edge. So that's, like if you wanted to debug on a specific network in Tokyo, for example, you can do so from the convenience of your laptop, wherever you are in the world. So once customers interface with those devices, they can engage in what we call capture. Capture is recording their test session, whether that's a manual session or automated session. They essentially have to either click a button to enable profiling or call an API, a REST API. But essentially what we do is we interface with the native debugger on these devices. And again, these are just bare metal devices, like any consumer would purchase. And we just enable the debug mode on these devices, and we can capture data from those. That data, once it's captured, is uploaded to the HeadSpin data platform. In the cloud, this is based on AWS currently. And for on-premise, we have a server that we deploy. In the data platform, we analyze that data using a variety of different machine learning models to enrich the insights from raw data like the screen recording and other data that we're capturing from these devices. That includes things like issue detection, and this helps support use cases around root cause analysis and regression intelligence. So being able to identify regressions, being able to identify issues proactively, and then dig in deeply to understand what those issues are. And then as a part of the HeadSpin data platform, we also support various ways of interacting with data, which include a Postgres SQL data pipeline, which we call the Replica database. And this enables customers to ask very specific questions from their data, ingest their data into their own data lakes or data systems, as well as build dashboards on top of all of the data that we produce. And we really work across a wide variety of different verticals, app developers, device manufacturers, telcos, banks, video streaming, OTT. Ultimately, this infrastructure enables us to support a wide variety of different customers to test and develop insights around the connected experiences that they're trying to provide to their customers. So ultimately, what are customers trying to accomplish? Well, typically customers will fall into one of these four categories, at least generally. And then there are a variety of different specializations within these categories. So I'll just cover at a high level what these are. Proactively detect high priority issues. So not only detect those issues, but be able to identify exactly what they are and do root cause analysis. And to do that while testing across different applications, networks, and devices. Many customers also want to measure key performance indicators. These are called KPIs, and you'll see that terminology used frequently. In that case, customers are looking not just for the issues, but for very specific performance metrics. And they may be benchmarking either against themselves for trying to achieve performance objectives within their organization, or against competitors to make sure that their application performance is remaining competitive in the market. And then finally, pass or fail builds or changes leveraging automation. So many customers will run manual tests on the platform, but the automation around the data analysis and collection actually saves a huge amount of effort. In addition, most of our customers will actually interface with the product via automation. And so they'll run automated tests, they collect data, and we have a very well-developed data pipeline to enrich that data, make it accessible, and to enable them to make go, no-go decisions on either a new build that's coming out, a new version of their application, for example, or changes in, for example, infrastructure that they're experimenting with and trying to decide, does this actually improve the end user experience? So how do customers actually collect data? And ultimately, customers need to acquire, or the terminology we use is lock a device. When a customer locks a device, they have access to that device exclusively, and then they can set up whatever their test scenario is, enable recording, which we also call capture. use the device, go through their entire user journey, their entire workflow, and then end recording. At that point, they can clean up or do anything that they need. But I just wanted to quickly show what this looks like in the product. And Scott went over this somewhat in the previous meeting. So I won't spend too much time here, but here we have a Google Pixel. This is in the remote control interface. What I'll do is I'll go up here to start recording. I'll just click this and I can select with network or without network. Here I'll go ahead and select with network. You'll see the starting indicator. Once this button turns green, then recording is enabled. I can go ahead and do something like open the browser just to some website. I'm using cnn.com here just for fun. Once this loads, then I'm just going to go ahead and stop recording. It'll ask me if I really want to stop, and then I can open up the dashboard view of that session. Perfect. So again, these are ultimately bare metal devices deployed inside this P-box. So what we're doing, and if you think about it, it's actually really wild, right? I'm here at my laptop, I'm accessing a device in Mountain View, which is a few towns away. So it's not that far in this case, but I could be anywhere in the world and accessing that device. And I'm actually interacting with that device from my browser, driving that device and recording all the data streams that we pull for that session and getting really deep insights into what was happening on that particular device. So I can actually, maybe I'll just show this in the UI here. So now that I have recorded this session, here I have a variety of data, but some of the primary data streams that we're capturing include, for example, the screen recording. So here you can see exactly what I was doing on the screen. In this case, there's not too much activity because I just launched this one web page. And we also record a variety of primary data artifacts. So you can see, you can download those from this downloads button in this title pane over here. The screen recording, we have HTTP traffic, a few different views of that. The binary network traffic, which is called the PCAP, as well as the TLS keylog that's needed to decrypt the traffic. So if you wanted to open this in Wireshark or some other program and do a deeper packet level analysis, you can do so. We also capture the device logs. Just to be thorough about this, so we capture the screen recording, network traffic, and that includes HTTP, TCP, TLS, UDP, and WebSocket. And these are surfaced in standard formats like the HTTP archive, which is a JSON format, and the binary PCAP file. Device metrics, which include CPU usage, memory, battery usage, FPS, input, output, and others. Device logs. So those are for Android, that would be the logcat. Automation logs. So if you're running an Appium or Selenium script, we'll automatically capture those automation logs and make those accessible. And then operating system level data, such as the foreground app and app activity, which application you're currently using, as well as which screen within that application you're using. For Android, we support the graphics debugger metrics, including frame rendering stats like janky frames, slow UI thread, frame render percentiles, and so forth, as well as user applied annotations. So when we interface with these devices, we capture a wide variety of data streams, and then users can also apply their own data via session tags and session labels. And we'll talk about that in a moment. And finally, we also capture the client-side method call stack. And this is This is a feature that we've adapted from Nimble, which is a company that we acquired a few years ago. And this gives really deep insights into the client-side code on the device and what's happening in terms of the call stack. So just wanted to dig deeper into annotations. So basically annotations come in two forms. There's the session tag, which is shown here. Session tags are key value pairs that you can attach to a session. You can think of a session as being, it's essentially a living document of the recording and all of the data and metadata associated with that recording for a particular test session. So these tags are, key value pairs that you can attach to that session. And then you can also provide annotations in terms of events on the timeline. So you can create custom events on this timeline. One of the really powerful, really powerful features with HeadSpin is that not only do we capture a wide variety of these data streams, but we, of course, do the analysis of those data streams. We align them on a common timeline so that you can scroll through this timeline. Here from left is the beginning of the session. At the right is the end of the session. You can see as I scroll through this timeline, the screen recording updates. And I can also see exactly what's happening in terms of, for example, our video quality metrics, in terms of the audio and the audio volume, in terms of various network metrics and various device metrics such as CPU usage, memory usage, and so forth. Here we have our Android debugger, graphics debugger metrics, and then we have Wi-Fi signal strength, latitude, and longitude. So if this device is moving, we can know that it's moving. And on this timeline, you can just click and drag. When you click and drag, you see this create label interface, and I can create some arbitrary event on this timeline that shows up in the context of all of this other data. And so if I'm doing this as part of manual testing, I can apply annotations. I can share that with my colleagues. I can also, as a part of automation, be able to apply annotations and create custom KPIs or add additional context to my tests. And if I have some external data source that I want to import data into HeadSpin, I can do so via these annotations as well. Perfect. So yeah, that's just what I covered with those annotations. One thing you can also do is you can leverage annotations to provide context to the analysis system. So in that case, basically you say, you can ask a question of your data leveraging annotations. So in this case, what I'm showing here is this on-demand analytics feature, which we call the page load analysis. This is a computer vision-based algorithm that's going to look at the screen and measure how much information is displayed on the screen and identify when a page offload occurs and then when the page load completes. So you can apply a very generous, essentially region of interest, which is this gray label here. When you do so, it will spin up an analysis. You'll see this analysis in progress indicator in the title pane. And then when it completes, you'll see the actual KPI as measured by the HeadSpin analysis. So you'll see the very precise timing in terms of when that page offload occurred and when the page load completed. And what I'm showing here is the page content time series, which you can think of as the amount of information displayed on the screen. And so this app essentially offloads and then progressively loads. And then once it reaches load completion, that's when the metric ends. Perfect. So in terms of the data that we add, of course, there's the primary data, the annotations, and then derivative data. And those include time series, the issue cards, as well as summaries. And so we've seen, for example, many of these in this session that I captured here. The time series include like our video quality time series, which are looking at the screen recording and profiling it for subjective video quality and various metrics. Issue cards are going to automatically highlight any issues in the user experience, in the performance, or any anti-patterns that we notice. And there really is quite rich analysis here to be able to render and display this content in ways that is useful and accessible. So for example, we can look at CNN.com, we can open up the TCP connection that this content was served over. You can see the exact timing information in terms of the connection setup, as well as all the requests that were happening on this connection. So, as we evolve, or as the data system, as we go through this data system, I'll actually just go back to here. We can pull up the performance monitoring tab. So here we have one particular session, and this is part of a list of sessions that you can look at in the performance or sessions tab. So when we open this up, we'll see all of the sessions that we've reported in chronological order, in reverse chronological order. Here we go. So we have the session that I just recorded. You can see, you can open it up in the UI. And then we have all of our user flows. So just going back to the session, I can add any session to a user flow. A user flow is conceptually going to be like one automation script that you run again and again and again, or some manual test that you're repeating multiple times. So a user flow is one user journey, and we leverage user flows in terms of being able to pass or fail a particular test, as well as aggregate data from those user flows, monitor trend lines, and make comparisons within similar sets of sessions. So what I can do here is I'm just going to create a new user flow. So this is going to be my demo CNN user flow. I'll go ahead and mark this test as passed. That will just indicate that there were no issues in terms of executing this user flow, and that I am satisfied with the data that I'm getting out of this session. When I create this user flow, which will hopefully show up here shortly, you can see I have this demo CNN user flow that is now added to my list of user flows. I can also view that user flow and launch it directly. And you can see I have my one session here. So each data point is one session. I can look at metrics that are aggregated for this session. There's a huge number of metrics, but this view is essentially, we have a timeline. We have our sessions as data points, and we have the metric, the device, and the geolocation. And we can slice basically our trend line view by these three different parameters, as well as by the timeline. And you can select the start of this timeline using this date range. In some cases, customers have user flows that have been running for years using automation. So in that case, we typically only surface the most recent data. And then you can access all of our data via the Replica database, which we'll talk about here shortly. Great. So once we have the sessions, we have this concept of the user flow, we can start making comparisons between sessions. So in this case, we can do, for example, comparison between two recordings of the same session, and we can do really a deep comparison. We can see what's happening in terms of the screen recordings and the timeline of those screen recordings. We can see what's different in terms of the issues, in terms of the network traffic, and do these really deep comparisons, which are prioritized based on the magnitude of the difference. We can also do this in aggregate, which we call our regression feature, or regression intelligence feature. But we can use those session tags that I mentioned earlier to actually select sets of sessions to compare. And we can do an aggregate comparison, a mean or percentile comparison of the different KPIs that HeadSpin records, and be able to pass or fail builds or other changes based on specified thresholds for these KPIs. Great. So I mentioned earlier the Replica database. The Replica database has a variety of different tables, and these include, the session metadata, the tags, the time series, the issues, the network traffic, the method calls. So anything that you would want to access in terms of the session data, you can access via our Replica database. And this Replica database is just a Postgres interface database. For our cloud deployment, this is Redshift, but for on-premise, this is just a Postgres database. And you can, really drive custom, very specific queries to, answer any questions that you might have, or measure any particular metrics that you might be interested in, whether that's from a single session or across many sessions. And one application of the Replica database, I mentioned earlier, you can use the Replica database to ingest data into your external data systems, but you can also leverage our out-of-the-box dashboards, which are built on top of the Replica database. So here I'm just showing our default home dashboard, but what this is going to do is just show the pass-fail rate for various tests on the user flows that you've created in your account. And these dashboards are built on top of the open source Grafana tool. So they're completely customizable. In fact, we can go in here, we can launch a dashboard. So you can see exactly this dashboard. You can click through it. You can open up a session if you want to using the session link. You can, of course, richly interact with the dashboard. And also you can customize the dashboard. So you can either go here and add a new panel, for example, or you can go to the title of each dashboard, click on edit, and you can customize this particular panel, or just look at the database query that we're using in order to collect this data and render it. So really powerful. In fact, most of our customers use dashboarding at some point in time, and the dashboard is often really the entry point, or the primary point where customers will engage with data, and then they'll leverage the rest of the data system to really deep dive their data and identify issues and debug. And the final, I guess the final point that I'll mention in this section is that we also provide alerting. This alerting is built on top of the comparison feature. And basically what we can do is we can push proactive notifications when we detect regressions, whether that is part of a CI/CD process, or if you just want to monitor performance longitudinally as you are continually running tests, you just want to make sure that your performance isn't degrading over time. We can continuously monitor that using what we call the regression alert watcher feature. And you can select specific KPIs and thresholds and be able to push alerts when regression is detected, as well as when that regression is eventually resolved. So that rounds out the HeadSpin data features, essentially what data looks like in HeadSpin. At this point, I wanted to focus in on HeadSpin issue cards a little bit more deeply. There's a question for the session compare UI option. So I'll just go in and quickly show this. But you can, in any particular session, in fact, I may have a session pulled up already. So in a session, you can select sessions to compare using this compare sessions feature here at the bottom. You can add the current session, and that will give you one session to compare. You can navigate to another session and add that session and then launch the comparison. So that's if you want to do a one-to-one comparison. If you want to compare sessions in aggregate, you can use that. You can use this regression integration here in the user flow pane. You can select tags. So if I want to, select two sets of tags, I can do so, and then you can. This will select the relevant sessions. You can click view regressions to launch a deep comparison between those and do an aggregate comparison. So these are kind of the two entry points in terms of the UI. Of course, everything in the HeadSpin platform is also API driven. So you have really full control over comparisons, leveraging the REST APIs. And you can find information about the REST APIs in the documentation, and for the comparison feature under the regression intelligence section down here. Perfect. Okay, so at this point, I'll talk a little bit more about HeadSpin issue cards and what those are and what they mean. So you've noticed in the UI on the left-hand side, there's this panel that shows the impact time as well as all of the issue cards that we surfaced for that session. And so issue cards are basically, they're automatically going to highlight problems in the session data, and they're going to measure what we call impact time. And so impact time is ultimately the amount of the session time affected by this issue minus some performance benchmark time. So in the case of loading animation, for example, we're detecting these buffering or preloader animations, and these are just indicators of loading. They're often a source of frustration in terms of the user experience. And so when we surface these loading animation issue cards, we only surface those issues if the animation persists on the screen for more than 1 second. And so you can see we describe that in the issue card description, that there's a 1 second that your application had a loading animation on the screen for more than 1 second. And so you can think of this as, we don't expect applications to have perfect instantaneous performance, right? Applications are connected. They have to fetch content over the network, and that takes some time to do, just in real life. And so what we do, instead of just surfacing that, hey, there is a loading animation, we try to prioritize the issues that we show to customers to make sure that they're relevant and have some impact to the end user experience. And we know that the highest priority loading issues are issues that persist for more than 1 second. And that's because studies by Google and others have shown that after 1 second, users mentally disengage from the workflow that they're involved in. And so you've now lost your user after loading for more than a second. And so what we'll do is we'll measure that amount of time above 1 second as what we call impact time. And we surface impact time as a top level metric for all of our sessions. In fact, I'll just go back to my CNN session here. Oh, I have it up here. So we have this union impact time. So basically, this is impact time for all issues. And you can think of this as how much of the session was affected by issues. So this is bounded by the session duration. And basically, if 100% of your session is affected by issues, you have some real problems, right? And then, of course, each issue card has various what we call impacts. So, for example, if I want to dig into this slow downloads issue, you can see that there are some slow downloads that are especially slow. They take almost 8 seconds to load, and there are some that are slow, but they actually don't really affect the performance all that much. In general, the slow downloads card is surfaced when HTTP responses take longer than 500 milliseconds to download. And you can always click on this view table to see a table view of exactly what's happening in terms of this issue. You can download that as a CSV or access that via the REST APIs. And when you click on an issue, we automatically highlight the relevant slow downloads. So you can see here are highlighted in blue are all the downloads that we consider to be slow. You can click on each of those. You can see exactly what's happening in terms of the request headers and be able to dig into that issue. So yeah, the anatomy of the issue card is essentially as I showed. You have the total impact time for that issue. So that's how much of the session was affected by this issue. Accounting for the performance benchmark. The total number of issues that we've seen in this session. So if this is one issue that's persisting for a very long time, then maybe you have just one really critical issue. If you have many issues, that are, we just show the impact time and the total number of issues. And you can see the impact time per issue highlighted in this bar chart. For each issue card, we have an explanation as well as suggestions on what you can do in order to dig into this issue and also to resolve the issue. And then finally, we have that summary table down at the bottom. The view table button just opens the summary table, and then this .csv button downloads the table directly. So we've covered this loading animation issue example, but we'll talk about this low page content issue. So page content is one of the time series that we surface as derivative data. So this is measured from the screen recording, and you can think of this as the amount of information displayed on the screen. So for intuition, down here we have a blank screen. At this partially loaded stage, we have a partially loaded screen. And then here, when the application is fully loaded, we have the fully loaded screen. And what you'll see in the session is that we surface these orange bars, which are, we call impacts, but these are specific regions of the session that are affected by this issue. And we surface what's called this low page content issue card. So page content is the amount of information displayed on the screen. Low page content indicates that you have a blank screen, essentially, or a screen that has very little information displayed to the end user. And that screen can be a white screen, black screen, any color. It can be a gradient, right? It's just that there is very little consumable information displayed to the end user. And then just as another example, we also surface the client-side call stack if you have a debuggable app and this feature enabled. So here I'm showing this is our call stack data visualization. This is, again, aligned on the same timeline as the screen recording and all of the other session data. So that gives you really deep insights into what's happening in terms of the code on the device and how that affects the entire experience. With this, we also have issue cards that we've adapted from the Nimble product, which include like the hung CPU method issue card. So this issue is raised when the application requires so much compute that it blocks the UI from refreshing. And we automatically surface those. You can click on the view table. You can see exactly which method is affected and how much compute it's using.